I gave this speech in Melbourne last night where it was about 20 degrees cooler. No kidding, got off the plane and was glad I brought a jumper with me. So this is my second tilt at it. Hopefully I do a better job because I've got a better audience to impress. And yes, we did do the same Sydney is worse than Melbourne banter when I was down there. So I won't tell you which side I was on. Helidon Kubernetes, or how I learned to stop worrying and love microservices. First question, who knows where I got the title from? Dr. Strangelove. Please bear in mind, Dr. Strangelove, or How I Learned to Stop Worrying and Love the Bomb, is a satirical movie. It was in the 1950s or 60s, late 50s, early 60s. It's a comedy. A lot of what I say about Node.js tonight will be comedy. It's intended in good nature, but we are in a Java meetup, so we can afford to pick sides a little bit. Normally in my day job, I don't get the pleasure of doing that because I work for Oracle. Speaking of which, that's a safe harbour statement. It basically says, don't buy anything based on what I say tonight. I'm not to be trusted. Just if I say, look, this is coming out in 6 months' time and it comes out in 7 months' time, that puts everyone in an awkward position. But please still buy lots of Oracle. So why should you listen to me about microservices? Cloud platform architect, which means I'm a generalist these days. I do work for Oracle. I'm talking about some Oracle products tonight. I will mention Oracle products. It's not an endorsement. I'm also going to talk about a lot of open source and other providers like Google and AWS. I still strongly identify as a Java developer, which is rare at Oracle because we've got such a diverse platform. Java developers aren't actually that common. 23 years of commercial experience with the language, so since version 1.02, right back in 1996. I remember tumbling Duke in the browser, thinking it would never be anything special. I was wrong. And I've previously been accused of being more interested in improving the way we do things than actually doing them. Hence now I'm an architect. So it's a good fit for me. So it's always good to start with a joke. And with that in mind, they will become important later on. But there's an actual joke behind this. Is God an engineer? So there's a project team sitting around on Friday night having drinks and pizza, much like we are. And the civil engineer starts off and he says, you know what, I reckon God's a civil engineer because he built the world. Obviously that's a feat of civil engineering. Got to be a civil engineer. And the electrical engineer says, no, you're crazy. Before he built the world, what did he say? God said, let there be light, which is clearly in the domain of electrical engineering. Therefore, God is an electrical engineer. Then the team scrum master says, no, you've got it all wrong, both of you. Because before God said, let there be light, he created order from chaos. So obviously, project manager, engineering project manager, scrum master, that's where you'll find God. And they pause and they look at the final member of the team, who's the software engineer, and she's sitting there quietly and she takes a sip of her Jolt Cola and just smiles and says, who do you think made the chaos? And the answer, of course, is microservices. So we'll start with a question. We've got to define what microservices are so that everyone's all on the same page. Can someone give me a brief description of HTTP? Just define it for me, succinctly. It's application protocol. Okay. Transfer protocol. We've actually got a much better definition than that. Okay, HTTP, Hypertext Transfer Protocol, is an application-level protocol for distributed collaborative hypermedia information systems. It goes on and on and on for 176 pages. But fortunately, we can say RFC 2616, we know what HTTP is. I can hand that to any developer with an internet browser and they can re-implement HTTP if they so choose. That's why HTTP is the backbone for internet communications, because independent parties can implement it. All our browsers can talk to all of our web servers. That's great. Microservices, on the other hand, in contrast to HTTP, are not very well defined. We don't have a clear, unambiguous, this is a microservice, that's not. So we've got a couple of guidelines. They've been around for about 5 years. It's more of an architecture or an implementation pattern. Before they were called microservices, they probably existed, like trees existed before we were calling them trees. They're typically lightweight, hence the micro. Typically rest over HTTP, and that's just your transport layer because it's convenient. Implementation agnostic, they lend themselves to a polyglot architecture, which means you can have Node working with Ruby, working with Java, working with C#, working with whatever implements that common transport layer, and they can understand each other. Basically, it's a discrete, independent component of a distributed system. So really succinct, you can argue the definition, but the things we're looking at are discrete, independent, and the scary one is the distributed system. So like all good public speakers, I did a little bit of research before I put this slide deck together, and I found avoiding microservice mega disasters, why you should never build microservices and why we do it anyway, mastering chaos. My favourite, kill microservices before it's too late, by Chad Fowler. I think Chad's had some bad experiences. I know a couple of other 10 tips for failing badly at microservices, another great presentation on YouTube. Have a look at them. Has anyone seen any of these before?
Yeah, why is the bottom one not your favourite?
The bottom one's my favourite because this is YouTube saying, you're obviously so depressed, I'm going to cheer you up. Like everything else in your feed has brought you down.
Was directly like,
on the cat.
sounds great. That's
Yeah.
microservice for me.
It's probably the best video on the whole lot. Right, so why are there so many cautionary tales? That we found a lot of negativity in those, in a lot of those videos. Early implementations failed quite badly. There was a case study in one of those videos about a large computer retailer who was running on their competition's hardware, and they decided to modernize. They went for a microservice approach and they failed. It took, I think, 9 minutes to render the homepage of the website they redeveloped. All of their timeouts were failing. When they ran it in production, and they tested it on their laptop, when they ran it in production, open up the browser, it just stopped. And then they said, okay, ignore the timeouts, let's see how long this takes, and it was 9 minutes. They fixed it, they made it a lot better, but the first tilt at it, absolute disaster. Breaking a monolith into an API, collection of APIs, is computationally expensive. So we're now talking about a whole bunch of more computing going on under the hood that we previously didn't need to do. So if you're just calling a method in a monolith program, it just calls that method, updates the pointer on the stack, off you go, all of your objects are still in memory. Doesn't take that much. When we're talking microservices, we're doing a lot more work behind the scenes to get them to those discrete components. Demarcation of responsibilities, like so in software, you've got who's a good OO, you know, the OO tenants, separation of concerns, encapsulation, all those things. We've got rules and best practices around this, and sometimes it's clear and sometimes it's not. Have you ever worked on a project where someone's implemented a method twice? Sometimes it's two different teams, sometimes it's the same person who forgot on Friday what they did on Monday morning. It happens. And in the teams and the organisation and the management layer on the top, it gets complicated because you're no longer having this single code base. And distributed debugging is a nightmare. I mean, the less said about that, the better. Because if you've lived through one of these, like stack traces, who likes stack traces? No one really likes them, but they're better than the alternative. Right, so we'll take a look at a sample monolith architecture, and it's a web app because web apps are cool. It could be a terminal app or anything else. You kind of go in through a load balancer, maybe HTTP server, one or multiple of those, and then they hit the app tier, which is a giant single code base, and it's got different functions in there. It also takes care of your identity, security, logging, and resources. This might be in an app server. You might have written all of this code yourself. You may have lifted it from a framework. It'll connect up to a database at some stage. Pretty simple, what we all grew up on. Then service-oriented architecture came along. And this was a bit of a change. It was an integration pattern. Some people build a discrete app like this. Some people tie legacy apps to more modern apps. Some people replace legacy functions with a more modern app, and they still try and pretend it's one system. And as you can see here, we've got multiple applications now. So we've got an app tier over here, one over here, and one down here. And we've also got this thing in the middle called an enterprise service bus. It's a bit of a problem for us because architecturally we want discrete components. We want this whole plug and play, swap them out as we like. As soon as you put that ESB in the middle, it's not really a microservice system because you're now relying on that ESB. Could be worse because if you've got 10 applications in your organization and they're all relying on that ESB and sharing endpoints and resources and API authorization tokens, you're now encumbered. So you've got a tech debt that you've inherited from that ESB. The other approach is microservices. So it's very similar to that SOA one, only we've got now is 3 apps. They talk to each other. It's point to point. It's messy, it's chaos, but it works. You can see we're still sharing a couple of functions like our logging layer that we've got in this app, and we've got logging down here, and we've got logging down here. Both of these apps have resources and they talk to the data tier down here. So there's sharing, there's inter-process communications, everyone's kind of getting along fine. It's also got its own drawbacks. It sounds like a really bad idea given our previous people who failed in the first couple of years, and people still fail today. So why would anyone want to take this on? What's their motivation for going microservices? A couple of points, and again, because it's so vague, there will be 7 other points. You can contest these points, that's fine. It's open for debate. Agility, a component can be upgraded and replaced without redeploying the whole system. That's a big one. So if you've got a monolith and you want to change a function, you're updating that one code base. I mean, Git's great because you can have multiple branches and you can do features on each branch and you can merge them and you can combine them and you can work out whether you want to rebase or just throw it in the bin and start again. And that's great, you're still deploying a single unit. So if you've got 3 features, 2 of them are ready and 1 of them needs a bit of extra work, these other 2 features are waiting for that deployment window. Or they're shipping without that and then you've got to make sure that it's still working consistently. Scalability. So if you've got an app under great load and you can break it up into components and you've got a shipping component and a purchasing component and a catalog component and you find that the catalog component's getting all the traffic, you just want to have 20 instances of that. You don't want 20 instances of the shipping and the other one which aren't being heavily used, because then you're wasting resources on CPU, memory, disk, whatever your other resource constraints are, which aren't going to get the most use. Neutrality. And this is a big one. I made a good joke about Node earlier. It wasn't a particularly good joke, it was just nasty. We can now talk about a system which is made of multiple languages, and we don't care what those languages are. That's part of the charm of a microservices architecture. So if you've got an old COBOL program and it's got an HTTP interface on it, and you want to start modernizing functions one by one, you don't need to write them in COBOL. Or C# or Java. You can take a lightweight program like Node, something which is easily and quickly deployable, has a small distribution size, or Python, or a bash script, or anything which can expose that data in a format the rest of your system can understand, and build it up from there. This goes for teams as well. So if you can't hire any good Java developers because you're busy working on projects and you need to go to the market and there's an abundance of Node developers, you can take those Node developers on. If Node falls by the wayside or Python goes away, just replace it with another language later. Complexity, that's another compelling feature. Once something gets too big for a single code base, on the management side, it can be easier to break it up into a couple of different discrete teams with a narrower focus. And that can give your developers better focus, you'll get better results, your managers will have a smaller remit, they won't have to worry so much, so long as you've got that one role in the middle which coordinates all of these different units of work. And independence. Anyone here a contractor or work for an outsourcing agency? Oh, okay, well, it's not so good for you guys. But you can, if you're building a system and you're not going to meet your delivery schedule, you can break off a chunk and just outsource it. And now if you're working for a company which does outsourcing work or contracts, this is great for you because you can now just say, oh, you've got a feature, you want to take a date and you want to get the weather in that location for the past 7 days or whatever, or you want to run some machine learning over this set of data, we can do that and we'll ship it back over a REST interface. Does it need to be in the same database or on the same server? It doesn't. Okay. So the decision often to implement microservices is organizational or operational rather than technical. They won't run faster. We know that. If you've got a monolith and it's all in memory and it's all in the same process, that'll be faster than running microservices and the inter-process communication. So why the recent interest? Diversification of the development landscape. We've got more languages, they're coming out faster. We've got Ruby, we've got Node, we've got things which are coming, things which are going. We've got Go. And there are more platforms, so more operating systems. Everyone says, yes, it's all Linux. Okay, but you've got Linux, you've got Mac OS, you've got Windows, you've got different flavors of Linux, you've got, I don't think we've got any new operating systems coming, but if they did, IoT might run on a Linux kernel, it might run on QNX, it might be on an operating system that BlackBerry bring out. As long as you adhere to the standards of microservices architecture, you can operate with any other component. Elastic and cloud computing fits nicely with the architecture, so resources on demand, that whole scaling flexibility has enabled us to not focus on a single deployment unit, but actually change our deployments over time or within a single release, scale up and scale down the features. Nomadic developer workforce, so average developers' time at an organization is about 2 years. Average project cycle, 4 years, some 7 years. I've worked on projects which were 20 years old. and you don't have that consistent developer workforce. If those skills go away, or even knowledge of that particular function goes away, it's not as much of a problem if it's a discrete chunk of work. You can just break it off, and if you need to re-implement it, to update it, you can now do that. And technology advances in tooling like Docker has been a great help, because it's all great to have these little programs. You've still got to tie them together. You still need to deploy them. And until we had the technologies to do that, it was more manual, it was more error-prone, it was more hands-on, and it was more specialized again. We'll take a look at a couple of the contrasts between Java and Docker in a few slides' time. So is Java a little late to the party on this one? There's not that much talk around Java and microservices. Node.js, very popular with microservices. Go, smaller, lightweight. Node.js, I mean, single-threaded applications are great for that because you can scale them out. You don't have as many concurrency issues. Java's been seen as a heavyweight alternative. So remember the app servers that who's worked with Tomcat and WebLogic, WebSphere? Yeah, the hands go up for WebSphere. A WebLogic installation you can run as a microservice. It's 1.3 gig. I mean, it'll work your network and it'll work your disk, but you can still deploy it as a microservice. But that heavyweight nature has been a bit of an impediment. What you'd normally do as a Java person, run up your app server and then deploy your servlets to it, or your EJBs, and they'd sit there and they'd be managed by that container. Solar implementations are abundant. So if you're going to do a microservice in Java, you would probably run it through an ESB because that's a technology you're familiar with. So it might only be a small function, but you don't really think of it as a discrete component. Java app frameworks, like Spring Boot, are still seen as bloated, even though you can make them quite small. Like with technologies like JLink, you can minimize the distribution size and you've got a nice little annotate a couple of pojos and I've got an application, but they're still often regarded as a little heavyweight for a microservice. And maybe we have better alternatives. So we'll talk about Docker now, and that's the encapsulation or containerization technology, came from the Linux world. Very handy. You have something that runs Linux, you run up a Docker host, you have a Docker container, it will run on that Linux Docker host. Doesn't matter if it's Ubuntu or Red Hat Enterprise Linux or you change flavors halfway through. So long as it's a Linux kernel, it will run those Linux Docker images. They like them because it gives you encapsulation of dependencies. You can bundle up all of your libraries with the application, deploy it as a unit. Well, I mean, we did that with jar files, war files, and ear files. Our ear files even had metadata in them that would tell you about that application, and the app server could interrogate those files so it knew how to run. It knew where to find its resources. Platform independence. I mean, really? We had this back in the 90s. We were running Java kernels with the JVM on HPUX and Solaris and Unix flavors, and they came and went over time, and the Java virtual machine was platform independent. Runs on your mobile phone these days. Repository of artifacts, Docker registry. Well, we've had Maven repositories. And as we go down the list, you can see most of the stuff that that Docker brings, we've had in another form previously. But it wasn't always microservices friendly. So the decision again, even though we've had these technologies, we haven't had that organizational push towards adopting microservices. So Java has lagged a little bit, but we're on the road to fixing that. So why don't we want to resist the trend? If we've got all of these app servers and we've got our jar files and ear files and we can do all of these consolidations and inter-process communication, we can do that. Well, we want to play nice with the other kids. Operations and DevOps. If you're deploying an application, it has to run on something. Who wants to be a Linux sysadmin? Just raise your hand. Wow, no one. Okay? So when you're talking about running your application, you still have a JVM. You're still talking about there's an operating system. We don't want to worry about that. Java abstracts that away from us. I had another architect take a dig at Java programmers saying, they're just like C programmers, except they don't understand hardware and they don't want to talk to it. It's like, why would you want to? I don't want to work out whether I'm writing to a single disk or a RAID array. It's of no interest to me. I just want the file to end up there reliably. So your operations team, we still have to play nice with them without taking on their responsibilities. Microservices have good OO, so object-oriented design elements, separation of concerns, encapsulation, code reuse. All of these are good things. So we want to make the most of these disciplines, not just for ourselves, but for the other teams we're working with. You can retain the control of the execution environment if you want to, but again, this comes back a little bit to do you want to be a developer? Do you want to be an ops person? Do you want to be a DevOps and be kind of in the middle? With containerization, you can, because you can actually build that Docker image and give it to your ops team. They just deploy it. You can take care of the JVM. You don't have to worry about someone in ops upgrading from Java 6 to Java 9 overnight, not telling you, and then ringing up saying, why doesn't your app work? It's crashed. Like, what's gone wrong? Because it was out of your control. If you take over control of that containerization, you then provide them the environment it runs in. Write once, deploy anywhere. Sound familiar? Again, once we've got containerization in our operations landscape, we can send it to multiple cloud platforms, on-premise, doesn't really matter. It's one less thing for us to worry about. And we can displace the pesky Python developers one component at a time. So replace that with C#, Node, Java, or whatever. There's two faces to that. So you can chip away at systems. Anecdotally, Netflix, big adopters of microservices. Write it in Python once, test it, works, deploy it to production, works, deploy it full scale to production, crashes, rewrite it in Java. And that's cool, because if something stops working in production, you can rewrite it in Java, you can scale across, you can handle these failures a little bit better. Right. So the story so far, we've had with Java technology, servlets running in app servers. Wasn't really microservices. Again, it's a large distribution size, 1.3 gig for WebLogic. EJBs, who's worked with EJBs? Ooh, about half the room. That's much better than Melbourne. I think about 2 people in Melbourne have worked with EJBs. So for those who haven't, it's okay. For those who haven't, in EJB, Enterprise Java Bean is a way of having 2 components talk to each other in Java. Now, it uses a platform-neutral mechanism underneath, Corba, or it did in the old days, it might not now, I haven't read the spec lately, but it's Java to Java. And it's great because it's just, I'm calling a method on this EJB stuff, it goes over, does something back there, what's my result? It's a Java object. This is fantastic. I don't need to worry about serialization and all the rest. The downside is if I'm calling a REST service, it's going to get this Java object serialized and say, I have no idea what that is, why can't you give me a JSON file? So then you're left writing boilerplate to convert your Java object to JSON so that the REST guy can, and it's a nuisance.
You still have to explain that previous slide where you compare EGBs with Docker Compose.
Okay.
I wrote it down, so that's for later.
Okay, please, yep, we will answer the question. So I will throw to questions later. App frameworks, again, ops dependent, so you need someone to have, anyone use struts? Oh yeah, you're a lot slower to put your hands up then. Which version of struts? It's always, a lot of people on 1.1, yeah, and you saw what happened with 1.1 and Equifax, and there's vulnerabilities, and you need to keep your packages up to date, and is it a struts 1.1 app or a 1.2 app, and if your ops people aren't going to support both, but it becomes a bit of a mess. And then there's the ad hoc one at the bottom, Java, Jetty, JaxRS, Groovy, maybe, struts, who just roll everything in there so long as it works, it doesn't matter. Until you've got a BAU team, business as usual, who have to support this into the future. So really there must be a better way. And that brings us to Helidon, which is a product from Oracle. It's an open source product. It's been developed by the WebLogic team. So the people who make that giant 1.3 gig distribution also make tiny little jars, which are suitable for your microservices. It's lightweight, modular, standards-based, which is very important. We're going to spend a lot of time talking about standards, and brings 2 programming models. SE, for lightweight, super lightweight, it's just a jar, and MP, which is microprofile. Has anyone in the room, you work with microprofile or heard of it? One hand, good. I'm glad I'm not wasting everyone's time by talking about it then. It comes from the Eclipse Foundation, and it's a consolidated effort to bring standards to the microservices environment. Helidon brings you a web server. It takes care of your security. It provides health checks. It has metrics and distributed tracing and a bunch of other things. All you need to run it is Java 8 and Maven 3.5. You have optional components. If you want to run it in Docker, you need 18.02 and Kubernetes version 1.7.4 if you're deploying it to a Kubernetes cluster. We'll talk about that in more detail later. And it has some supporting tools which will make things a little bit easier for you, like Grafana and Zipkin and Oracle Engine for Kubernetes, which is just a managed service for Kubernetes. So if you're deploying your applications, you don't like YAML, this is a great option. How to start a project. So you can't get out of these things without showing some code. So if you want to set up a project, it's just a little Maven command, it's got an archetype, and for the SE quick start, that gives you a template and you've got all of your classes and stubs. For a MP, so that's the micro profile, it'll generate that. It's a slightly different Maven command. The two programming models that we bring, SE on the left is the core implementation, so that's the basic unit. MP sits on top of that. Webserver.create, routing builder, greet, request response, response.send, hello world, build, start. That gives you a web server. It's not very useful, but in that many lines of codes, you've now got an HTTP exposed RESTful web service, which is pretty neat. And it will run. All you need to do, as we'll see in a couple more slides, is type in a Maven command and a Java command, and you're now running a web server. On the other side, where we've got the micro-profile version, annotations, get, path, JAX-RS, we bring a little more tooling to it. It's a little more heavyweight. You might be more familiar with this model of programming, so you can use it. Most things that they bring to Helidon come in twos. It's a little bit bizarre. So it's powered by Netty, which is better than Jetty because it's not just an HTTP server, it supports other protocols as well, so you don't need just to be sending text over HTTP, you can send binaries. It's got support for large file transfers, which makes it a lot nicer for dealing with different types of data. Programmatic HTTP API, you type it all in. The config is really nice. Config comes from 4 different sources, and you can of course wire in others. Properties file, class path loaded. If a config file changes, it'll pull that config file and say, okay, this has been updated. I'm going to change while it's running. It'll update its own internal configuration. Config formats, YAML, HOCON, JSON, Java properties. Security will provide authentication and authorization. You can read all about this on the website, so I won't go into too much detail here. With MP, we get JAX-RS. Anyone use JAX-RS? Please say yes. Yep, good. So that's the RESTful web services. It's the Jersey implementation, and you annotate a POJO, you get REST out the other side. Really handy. CDI, context and dependency injection, so injection of components at runtime and chaining commands and the likes. JSONP is just an API to make your JSON a little bit more user-friendly. It's a lot like Stacks and DOM were for XML. Has anyone used those? I see the hands are getting smaller as we get older and older. So Stacks and DOM, you'd build an object and you get an XML string out the back. No more sitting there string builder.append, .append, .append. So it's a convenience method. When we want to actually build one, all we do is Maven package. To run it, Java, and we point it to the jar in the target folder. To test it, we run curl, or you can put it into a browser, and we get that hello world. So from a couple of lines of code, you've now got that running on your desktop, and with a little bit more work, we can get it running on clusters automatically. Right. Surviving microservice failures or don't be on the hill. So remembering those YouTube videos which were all pessimistic and everyone had a really bad time, who knows the acronym MRLS? Can anyone expand that? You might not have heard it in technology, because that's what it's for. Multiple rocket launch system. Okay, so I had a friend in the army years ago, and she really liked tanks. And when one drove past the office window, because that happens when you're in the army, she'd get up and look out the window and she'd, cool tank. People thought she was crazy because you've been in the army 10 years, you shouldn't be excited by tanks anymore. But we were talking one day and she mentioned this thing which is an MLRS, multiple rocket launch system. And she said it's like that thing in Iron Man. You've seen the movie where he's testing the Jericho missile and it takes off and it flies out and separates and it hits the hillside. And the whole hillside just explodes and there's dust everywhere and a giant shockwave. She said, it's a lot like that in real life. Not quite as big as the movie, but, if you're on that hillside, you're having a very bad day. And I asked her, so how do you counter that? If you've got a squad of troops out there and you've got one of these, what do you do? And she said, simple, don't be on the hill. Survive microservice failures by not failing. And yeah, it's a little bit glib, but this is our tactic. Every piece of software will fail, it'll break, there'll be bugs, things will be unexpected. In an environment like this, it's going to be a little bit more complex to fix. We build in resilience. Testing, all of your tests are now effectively unit tests. Why is that? Because your program, your application, is going to be called from somewhere else and you won't know what it's passing in. So you can't really treat this as anything other than a function. You've got to sanitize your input coming into it. You've got to check for, I was going to say buffer overflows, but we're not C programmers. You don't know how it's going to be treated in the future. If scalability is a concern, you need to test what you're running on, your network, your disk. The case study from the videos earlier, they saturated their network. They couldn't keep up. So they bought a bigger box and they put more networking in it. And they basically, the guy described it as, you know, when you go shopping for a computer online and you just add all of the options and try to make the most expensive thing that you can just to see how much it will cost. They did that and then wrote a check to buy it, to keep this thing running. So if you're going to deploy large systems, you need to test your infrastructure. Your dependency matrix is potentially the cross product of all of these services. Because if you return a response, something from your data model, a business object, you've got no idea where it's going to end up. So you need to maintain consistency over that data model for all of the components which might be using that, or a field which has been derived from that business object. So it becomes a lot more complicated. Your documentation now comes in two flavors. You've got your internal project documentation, and if it's being consumed by other components, you've now got your API documentation. Who loves documenting code? I actually do. Hell is other people's code. So if you walk into a system and it's not well documented, you start to enjoy documenting your own code because you're thinking about who's coming after you. Post-deployment, tracing, metrics, and health check. These are all things Helidon provide. So each has its own role to play. And if we take a look at back to our architecture, we've got logging, logging, logging. You've got a single transaction coming in. Do you really want it logged in 3 places? If something goes wrong with that transaction, where are you going to look for a stack trace? Where are you going to find that error message? You'd like to have distributed logging with a single system, which is great. Does Log4j work really well in the .NET space? Or Node, or Go, or Ruby? Not really. So what we're looking for now is a way that the components written in different languages can actually take a transactional view of that request and log it as one concise unit. And that's where the tracing API comes in. So it relies on the open tracing APIs. Open tracing is a standard that you can find on the internet. It is, as it's a standard, it is like HTTP, it's portable. So you can have your other components, if they rely on the open tracing API, or implement it, sorry, they can then take a client over here, receives the call, the tracer will inject the user ID, for example, and then when it throws it across the wire by HTTP to the next component, it will extract the user ID or whichever other identifier you want from it, because it knows how to use that API. And that way you've got a consistent chain. So even if they have distributed logs, you can put them into Splunk or some other aggregator and get a single view of your transactions. Zipkin tracing is an implementation of that, which Helidon works with out of the box. And as you can see there, it will actually act as that repository. It'll collect your timing information, and we've got a nice little, over on the right, flow, kind of like a Gantt chart, so you can see which call out of that whole end-to-end transaction is taking up the most time, which one's failed, and the likes of that. It's an open source product, works with HTTP, works with Kafka and Scribe transport. So if you're doing really intense logging, you want streaming analytics on it, you've got Kafka for your ingress, and APIs are available in most languages. So again, we're playing nicer with the other kids. Once we've got our logging, we've got the option to have metrics, which are not basically, you're not looking for these in the past. This is runtime information. So each component's going to have its own resources and heap and stack and request counters and the rest. Metrics is a way of exposing these in a standard. So there's a microprofile standard, or you can use Prometheus, which is open source tooling. And we can see over on the right, we've got a nice little chart. And we can see we've got a blip in our HTTP latency at some point there when the traffic to that scaled up. So this gives you great runtime information that you can analyze. So now that you've got all of these services spread out all over the place, you'll want to be able to drill down, see if one's failing, see why it is, take a look at what's making it fail, and create your own metrics. So the implementation, a lot of Java code, we're basically grabbing a registry and adding a counter to it. We're doing a nice method reference to throw in, so every time we do a get, we increment the access counter, and then request.next throws it onto the next component in that chain. So that's how the API injects this step into your web server, so that you as a developer don't really need to worry about it on every single call. Has anyone ever worked in a system where you've had to do that? I've done it, it's nasty. because there was a policy, and they said basically when you call the SOA bus, first thing you do is profile point.start, and when you get to the end you have to call profile point.stop, so that it could then end up in the log file, which would then be consolidated, and it's a pain. That's that boilerplate that developers hate. So this is a way around that. So you can track anything you like in a metric. Memory usage, you can adapt your load balancing strategy from what you know about your services. You can adapt your partitioning strategy. So when I talk about partitioning, you know, databases will partition things. You've got alphabetic data, put all the A's on this server, all the B's on that server, all the C's on that server, and so on. You're going to have a lot more A's, B's, and C's than you will have Z's. When you're running a microservice and it's partitioned, so that depending on the data ingress that's coming into it, you might have 5 services for this and 3 for that. You want to be able to monitor this in real time to adapt. So if a particular service is getting overloaded, you want to say, oh, my latency is a bit high here, I'm going to put more databases there, I'm going to adjust my caching strategy or whatever. This is a real-time tool which allows you to do that. Health checks, which is going to lead into our next point, which is one of the key selling features of health checks, is that it's a standard. It's used a lot with Kubernetes, and it is to tell you how your application is doing. It's not like metrics, because metrics is like, I've had 70,000 requests. Health checks is basically, are you alive? Are you running? Are you ready to receive transactions? And again, like most things in the Helidon framework, it's based off a standard. And the reason for that is really important, and that's Kubernetes. I know I'm asking these questions a lot. Has anyone worked with Kubernetes in here? That's great. We've actually had a few people do it. So if anyone wants to come up and take the next slide where I talk about what it is. So a container, Docker container, is a discrete execution unit, and you can run it on a computer, and you can write Docker run, and you can pull and push and ship them around. That's great. When you're doing this 10,000 times, because you've got a massive cluster of applications under a great load, you don't want someone sitting there typing in Docker run, Docker run, Docker run. Oh, I've deployed the wrong version, pull these ones back, deploy this version, Docker run, Docker run, Docker run. So we want automated tooling around it, and that's what Kubernetes provides. It'll deploy, start, stop, scale up, scale down, define your system declaratively. And that's a nice feature, because your system, remember how we're all these discrete components? How do we know what is the definition of the system? Well, it becomes your Kubernetes file in a lot of ways. You can replicate the whole deployment. So once you've got that declaration, you can have one in test, you can have one in prod, you can have one in dev, you can have one in Jakarta, you can have one in New York, one in Tokyo, one on your laptop. And then you can tinker with them, so you can make them a little bit more laptop appropriate or data center appropriate, depending on your purpose. So it came out of Google. They developed it based on their work with their own container systems internally, and they've released it as an open source project, and you can also get vendor-backed versions of this. So Oracle have a version, AWS have a version, Google of course have their own version, which is the Google Cloud Engine, Google Container Cloud, something, I don't know. Just Google Kubernetes, you'll find it. It gives you abstractions around your service discovery, your storage, your networking. These are very important, and you don't need to worry about them as a developer. That's the best part of it. It has load balancing integrated because it takes care of all of these abstractions of your storage and your networking. Self-healing is a big selling point, so when microservices start to fail, we don't want to be worrying about it and reacting to that in human time. We want to get to it before it fails, see it's about to go down, scale our cluster, get rid of the broken parts, and not have our customers or users of the system even notice. And we do that with our process monitoring and custom health checks. So that's a YAML file, which is your, it's YAML, it's never going to be fun. That's a declaration of what an application looks like, and we've got containers, we've got the name of the container, we've got the port, so it's exposing a container port of 80. That's how it gets to the rest of the outside world. On the other side, we've got the Oracle vendor-supplied version, and that is just a nice web interface. So if you don't like typing away in YAML and working out where files are, this will give you a lot more options, a little bit more user-friendly, great for your DevOps teams. If you do like running kubectl, push, pull, run, deploy, you can just do it in a bash script. The architecture of Kubernetes is things are defined in clusters. You'll have a master node for the cluster, and then you'll have all these nodes down here. The nodes may be discrete computers, they might not be. You can run a couple of nodes on your laptop. You can run one node on one machine, another node on another machine, spread that across your data center, virtualization, VMs, machines. Oh, sorry, I said virtualization. It's really an alternative to virtualization, so you wouldn't run this in a VM. And they handle the runtimes, and you'll see that we've got pods down the bottom. And pods are where we put our containers. So the components of, say, a Kubernetes pod is a deployable unit. It is one or more containers. It shares network and data volumes. So there's a routable IP address so that your applications and other pods can get into that and access your services. It's transient, very important. They go away, they die. You don't know when they die. The system might just think it's time for this one to go. This one isn't performing, it's gone away. So if you've got stateful data, if you've got things that need to be like cleaned up and written to disk, that's a bit of a detractor. A replica set is then a collection of pods. And as you can see over here, we've got multiple containers or one container, it doesn't really matter. When you have a replica set, it will be a replica of that one pod. So if we replicated this pod, we'd have 3 pods with a single container in it. We replicate this one, we've got 3 pods with 4 containers into it, and the containers all know how to talk to each other. Deployment. Kubernetes deployment, which is a concept in Kubernetes, contains the declaration. It will define your containers, environment variables, data volumes, number of replicas, a lot of these abstractions that we're talking about. The invitation of a deployment creates the replica sets, and then the replica sets create pods. And all of this is done by processes running on your nodes. So the master node will send these commands out. You can send a REST call to your master node, which will then drive all these other pods and nodes. And modifying the deployment will create a rolling update. So you don't need to stop the cluster, change a deployment, redeploy it. It's really great for that blue-green deployment model. You keep one going, start up the next one, and then you take away the old one. Services are a very important concept because that's how your pods talk to each other. You can't have everyone on port 80. You can't have everyone dialing up loopback, can you? You expose a static IP address and a DNS name to proxy the traffic to the pod, so Kubernetes exposes that. And then Kubernetes manages the network segments between all of these different components. And it can provide load balancing with pod session affinity. So if a request has gone to one pod, it'll keep going to that pod, even though you shouldn't really be looking for that. How do you code to this? Because, I mean, back in the good old days, if you had an application that you were writing, you knew where your ports were, you had a server, you knew what was open in the firewalls, you knew where your routes were, you knew where your database was. It's not that hard. Because we've got so much internal proxying going on and the Kubernetes system controls the network that it's running on, and your pods come and go, you expose it through DNS. So you code basically to a URL. So if you've got a JDBC connector, you point that to URL. If you're making a REST call, you point that to a URL. And then Kubernetes will say, oh, you're calling the image database endpoint URL. I know that that's running on this pod over here. Or it's running on these 3 pods, and I'm going to hook you up to that pod. So that's how you code to it. It's not all about learning a service discovery API. You just code to your DNS. If you know the request string, off you go. You can bend the rules. So you can say, if someone says, you've got to be microservices now, build me a microservice. Just have a replica size 1, a single container, and there's a Kubernetes operator for WebLogic. So you can just 1.3 gigabyte, there's my microservice, and no one will ever be any the wiser, except the ops people are saying, why does this take 5 minutes to deploy instead of 50 seconds? So it is possible to sneak around things, but when you get familiar with this or comfortable with the idea of a framework or another application system owning your network and modifying it in real time, and all you care about is the DNS name, life becomes a lot easier. Right. So to summarize, microservices are still terrible, but we can do them better. And again, I'm being a bit tongue-in-cheek, but as a developer, I'm a little bit anxious about them still. I like having a single stack trace, even though it's never fun to dive through them. The reason we're looking at the microservices in Java specifically, and not just running out and doing Node and Python, is Java brings enterprise-grade languages and features to microservices. Like, we're all Java developers for a reason. Like, we like the platform, we're familiar with the tooling, we've got great APIs available to us, we've got great open source communities behind us giving us features that we can rely on. We've got great build technologies in the CI/CD chain. Java brings that. If you've got a customer who's a little bit anxious and they like support contracts, you're running Java, you can run it on a certified version. The Oracle JDK is certified to run on Solaris, Red Hat Linux, Windows Server, Windows Desktop, Windows 10, and it will not break, because if it does, Oracle are liable for that. Helidon is supported, so moving on even further, with an Oracle WebLogic license. So if you've got a customer with a WebLogic license and they're running this in production, and you have a problem with your Helidon framework, you log a ticket with Oracle, and we fix it for you. It's part of your support contract. There are very few open source projects which will do that, straddling the two worlds. Yes, you do have to pay for it, but you're still getting premium support from a vendor. Features like JLink will drastically reduce the deployment size. Has anyone used JLink? Oh, come on, even someone in Melbourne had used it. Like, it's not, I know you build your jar, you deploy it, that's great, I don't want to look at it. But if you're talking microservices, when you start throwing JLink into the mix, you can really minimize that payload of your service, which is a nice feature to have. Standards-based APIs, and this is a big part of the Helidon stuff when we're talking about our logging, our metrics, our health checks, things which the whole system needs to be aware of. We've got standards in place thanks to largely the Eclipse Foundation with the microprofile platform, so that all of these different components can work well together. And Java's mature CI/CD, as I said, we've got Maven, we've got Jenkins, we've got tooling, we're comfortable with that. So to add another step on the end of our Jenkins deploy or whatever, you push that to a Kubernetes cluster and it goes out, and then you've now got this amazing self-scaling, self-managed app made up of a number of discrete units, and it is actually a really cool technology to be a part of. A little bit scary, but if anyone's going to do it properly, it's going to be the Java developers, right? Have some confidence, guys. I'm sure you will. That's about all I've got. So thank you a lot for your time, and thanks DS for hosting. I'll throw to questions now. Please don't ask me any syntax that you can Google. If you want to ask what Oracle thinks about the future of Java, or why Node.js is better than Java or worse, feel free. And we'll start with the containers versus EJBs.
Yeah, so on one of your slides you said that the EJBs compared to
components, yeah. Compose. Okay, so Compose collects a bunch of different containers together. Yeah, EJB application is composed of several EJBs, or can be, so it's discrete components being collected together to expose an interface.
Yeah. From that point,
that's my justification. Yes?
Can you use Jackson?
Can you use Jackson? I am not. Well, you can if you just import it. So everything is just a Maven dependency. So if you want to use Jackson, you just declare that, you bring it in. And so Helidon doesn't provide that as its own component. It uses the JSON-P in the MP flavor. If you want to use, so the question was, can you use Jackson for serializing your JSON? If you declare it as a Maven dependency, you can use whatever you like. The version which comes with Helidon MP is JSON-P, which is a little bit more lightweight. If you want to go full on stacks and DOM and serialize to XML, just declare the Maven dependency, that library comes with you. Yep.
And can you do flame graphs?
Flame graph, if you, yep. So if you have, with the metrics, you can customize what you output, and it exposes a URL as an endpoint. So if you've got Cactus or any other monitoring type open source commercial system, as long as you can point it to that health check URL and it can interpret the JSON that you're providing, that'll work.
But everything's going to be based on whatever runs under the JVM, right? Nothing else, not from
yes.
the operating system point of view?
Yeah, no, not from the operating system point of view.
Okay.
Yep. Yes?
With this framework, will you continue to support microprofile in the future, and how like quickly will be the builds? Because microprofile, I think current version is 2 point something. So
yep.
Is it like you will continue to release as soon as we have microprofile version?
Yes, so the roadmap is to keep supporting microprofile and to remain current with that. I can't give you any guarantees on timings, but the intention is whatever microprofile is doing, Helidon will follow to make sure that we stay interoperable with everyone else who's using microprofile. Because as soon as the microprofile thing goes away, we lose a lot of that interoperability, we lose the polyglot advantage, and it's not such a great offering.
And if we are using the SE version,
yes,
right, not microprofile version, so still you are relying on the J2EE JEE specifications API, like, or it's different?
No, it's Java SE. So the Helidon SE is just a Java SE application. It doesn't expose any of the EE APIs. No. So when you use the MP, which is Helidon MP, when you just start from the different Maven archetype, then you get JAX-RS, you get CI/CD, and you get JSON-P. So you've just basically got to choose that project, the programming model at the start, and you'll get those EE APIs. But you're not doing a whole container deployment. So you won't have every feature that you want from the whole EE spec, and that's why micro-profile came about. Yes?
Does it add OpenAPI at some point?
OpenAPI as in documentation for your APIs?
Not so much the documentation. Like OpenAPI is also used as a specification.
Specification, yeah.
Generate clients of it.
I'm not 100% sure on that. I wouldn't be surprised if it does. I know Oracle uses OpenAPI in some of their other products, like their API Gateway. I don't know if it's included or if it's integrated with Helidon. If you've got libraries that implement OpenAPI or tooling around it, you just incorporate that as part of your Java project. So if you're already using OpenAPI, then you can incorporate it. Yes, the guy in the Java shirt. I was hoping I could point that out.
If we use Oracle Cloud, the great Oracle Cloud, which of these set of technologies are ready to use and we don't need to deploy Oracle?
Okay, so if you're running the Oracle Cloud, so we've got a couple of offerings in the Oracle Cloud. We've got Java Cloud Service, which is just a WebLogic container. The Oracle Kubernetes, Oracle Container Engine for Kubernetes is probably for the Kubernetes microservice is the service you'd look at. So it comes in two components. There's the container engine and there's the repository, and they're distinct, so you can run them as managed services. If you just want to run up some IaaS, so just spin up some Linux machines or Red Hat or Solaris and do all the coding yourself, you've also got that option. So who knew Oracle had a cloud? Guys, Oracle has a cloud and it's really good. Right, so we do have a cloud. I'll talk to that for a minute. If you go to oracle.com/cloud or cloud.oracle.com, there'll be a link to try it. You can get a free trial. You can try the Oracle Cloud. I really like it. It's we're about to undergo a slight version change from Generation 1 to Generation 2 in Australia. It's got some really nice technology in it. It's Oracle's a member also of the Cloud Native Computing Foundation, so we're very much into cloud native, meaning also polyglot, standards-based, playing nice with other clouds. So if you've got applications that are written for the C and CF type environment, deploy them in AWS, deploy them in Oracle, deploy them on Google Cloud Platform. Everyone gets to move their apps around and tie them together. Really nice features. So do have a look at it. You can get a free trial. It's lasts you about a month. It's $300 worth of cloud credits. Services are billed as you use them, so you can burn them down. If you're not using it, you won't be billed for those services. You can play with WebLogic. You can play with the Oracle database. You can do machine learning. You can do analytics. Anyone played with our analytics tools? No, they're really cool. I like them. You just stand up a database, suck in a whole bunch of data, right-click, explain, and it will tell you about that item of data. And it will say it's dependent on these fields or it's correlated with this. A lot of good stuff in there that as a developer, I never played with. And I'm now an architect. I have to know a lot about it. So yeah, if you do have any queries about it, come and find me after the presentation and I'll give you a business card and we can talk about it. Sorry, I have to go commercial. Larry's paying for me to be here. Yes?
You mentioned it's running Netty or based on Netty engine.
Yes.
Could you have hybrid 100 or JBoss 100 or something?
I mean, you could, but why would you want to? So if,
Lesser footprint wise.
or you've already got Netty in there. So if you've got other containers, like they're doing the job that Netty's doing. So Netty's basically just there to be the smallest footprint to expose an API. If you want the container functions and you want all the security integration and it's easier, then you'd probably look more towards just doing a servlet or something like that and deploying it to your existing containers. The microservice, the Helidon, is basically, we want to do the exposing of the API and everything that we can, and we don't want to do too much. So it's that middle of the road type approach. Yep. I'll say that you've already asked more questions than Melbourne, so that's good. One more?
One more question.
Yep.
how long it, like you started an open source project.
Yes?
For how long Oracle will support? Will it be like dump at some point in time or it will go along? That's the main problem with this project. Because if, let's suppose if I start using it in production, I want to make it a application based on that and
How long has Oracle been supporting Java?
yes you are, but
23 years, and that's, I'll point out that this came out of the WebLogic team, and it is developed by the same developers who develop WebLogic. So I can't give you any guarantees. It is a serious part of that team's focus, and they will be supporting it as part of the WebLogic family. So it's like their lightweight version of WebLogic. So it'll be around for years. And look, here's the best part. If it goes away, because we've coded to the microprofile platform, you don't care. You take your business logic, you wrap it with another framework. I mean, I'd be sad because I think it's a really cool tool and I'd like Oracle to support it forever. But if it does go away, because we've coded to the Open Tracing API and we've coded to these standards and the health check is the standard that Kubernetes expects, you can swap it out. If it doesn't work for you and you find a better alternative, you can replace it with that as well.
But if I'm taking this framework, I might take it for SE, not for a microprofile. The microprofile is still there. Why I will
Yep.
use this framework?
Yep.
Microprofile, just a wrapper of microprofile. So I will use microprofile, but I will take this.
Well, you still need a microprofile.
SE.
Sorry, you still need a microprofile implementation, so you need to pick one. So microprofile is just the standard, so you'll need to, like your JDBC drivers, there's a standard, you still need an implementation of that. And Helidon is providing that implementation of microprofile. Does that make sense? So it makes it a little bit, a lot more portable, but look, I'd love to give you every confidence in the world. What I will say, so as being part of the inside circle of Oracle, which 20 years I wasn't part of the inside circle of Oracle and I had my impression of what they were from the outside. Now that I'm inside, a lot of the information that came from this call and the confidence that I have in presenting it as a good product came from a conference call that I was on about a week ago, where some of the developers who were working on this project were talking about the features. And they opened it up to questions, much as we have here. And I was asking, can you use Netty for binary transfers? Can you do this? Can you do that? And all the answers came back, yes, 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 no, you can't do this. Why would you do that? So it's a product Oracle's taking seriously. They are promoting it to their internal working groups. We are actively involved in its development. They're taking feedback. So again, guys, open source. Do you want to make it better? Just join the project and start contributing. Do you want to make it better without doing any work? Get on the support mailing lists and the groups, and the developers and the community will drive its evolution. Yes?
I never looked at it, but what is the serverless offering that Google Cloud has?
The Google Cloud or Oracle Cloud?
Sorry.
Sorry, that's okay.
Google Cloud I know. So
Yeah.
that's
They're all clouds, they're all the same. Okay, so Oracle has if you go to fn.io, I think, it's the FN project from Oracle. That's our serverless offering. It's a platform neutral. Again, it does a lot of the work under the covers for you. It's open source. There will be a service coming which is going to be called Oracle Functions as a Service, I think. Now, this is forward-looking. Please don't quote me on it. Functions as a Service. It is going to be a lot like AWS Lambda. So if you've used AWS Lambda, it's a like-for-like replacement, and it's got a lot more of the managed services around it. So
it supports Java.
yes, it supports Java, and the FN project supports a handful of other languages as well, like Go and Ruby and yeah. Can I say your questions are much better than Melbourne's? Really impressed. Yes, down the back.
Kotlin taking off so much, will Java be around for like your backend tooling and all the rest? Are you still writing in Java, or are you moving towards a Kotlin language where you're not stuck to your compiler there?
Okay, will Java be around? Was that the question?
Well, will it be moving towards Kotlin? Is it going to Kotlin be a phase that will phase out for a while?
Right, so
Nothing on Kotlin. A lot of people.
Kotlin, GraalVM, Java. Oracle writes not just their tools in Java, we write our tools in Java. We are very involved in the Java specification and the OpenJDK project. Oracle is very heavily involved in the OpenJDK project. And Oracle makes a lot of money from programs which are written in Java. So it's our lingua franca, if you like. As for other implementations and other open source things, we've got the OpenJDK project. Other developers can come up with their own language specifications and the like. Within Oracle, the focus will always be on Oracle Java and the Oracle JDK.